Thank you so much for this kind introduction, and thank you for having me. Normally during a keynote I would synthesize a bunch of papers from the people in my lab, but instead today I want to highlight one specific project as executed by Mohammed Derekshani, Diraj Varghese actually when he was a master student doing this in his spare time, and our collaborator from Cohere Labs, Marzi Fadaea. And I want to talk about NeoBabel. So NeoBabel is text-to-image generation, and no doubt you have seen many text-to-image generation tools and results in the newspapers, and maybe you have tried them yourself, because progress on this particular problem of translating a sentence prompt into a realistic image has been really amazing. So I just highlighted 4 examples of a recent model. This is done by DeepSeek, but there are other models by any company you know of who is doing the similar things. And sort of super photorealistic. It's really amazing. This conference likes interaction, I have learned. So I'm going to ask you one question during this talk. Who of you originates from a country where English is the native language? Now, this is exactly the problem I want to talk about today. So we live in a monolingual AI world that is dominated by English language. And these models, so in fact, serve actually only 5% of the world's native speakers, because the rest of us speaks a different language. Many of us know English, but it is not our native language. So this here you see a map of countries where English is a native language and also the majority language. Some countries also have English as a native language, but it's often not the majority language, like India. And the fact that English is only native for such a small part of the population creates a significant barrier to global access to AI, and also strengthens digital inequality. So here's also a plot for Europe, where the situation is even worse. There's only one country where English is the native, or 2 I should say, Great Britain and Ireland, where English is the native language, and the rest of us speak a different language. So there is a need for a multilingual AI solution. This is an overview of text-to-image generation state-of-the-art for English-only language. And what we see here is on this axis the benchmark score, in this case NeoBabel, and here we see on the bottom, oh, what did I just do? On the bottom we see the number of parameters, right? So the more parameters, the stronger the model. But the interesting area actually in this plot is this, where you get very good performance for small amount of parameters. Now, this is the state of the art. Progress moves very fast. So here you see models that have been proposed in June and in May of this month. I was on holiday for most of August, but in the meantime, more models have been proposed. So this is really going really fast. Almost all these models are English only, so they absorb an English LLM, so to say, right? Some of these models also incorporate a multilingual LLM, but they never connect the multilingual LLM also to the pixels, right? So the connection between the pixels and the language remains English only. So none of them is natively multilingual. That is the key point here. And also, many of these models are closed. So they have very limited openness. So either the data is proprietary, the source code is proprietary, or the weights are proprietary. and only very few make them all available. Now, this is NeoBabel. We are here in this Pareto frontier. So we are, at least we were state-of-the-art end of July with a model that is 2 to 4 times smaller than existing state-of-the-art. It is fully open, so we make everything available: data, source code, pre-trained weights, the full package, so you can replicate it, use it, and improve upon it. And we have natively support at the moment for six languages. And as you can see, the closest competitor is Blip Trio. This is from an American company called Salesforce. And we also compare Blip Trio with our international benchmark. So we totally cover, besides English, we cover Chinese, Dutch, French, Hindi, and Persian. And as you can tell from the plot over here, we do much better for these international languages because we are natively multilingual. Now, my talk today will be about how did we do this, right? So how can a small team from a Dutch university be competitive with international companies doing these large English-only models? So I think this is also a message of hope for those of you working in academia, that these foundation models are not limited to big tech. They want to make us believe that you can only do it when you're at a large company, but it is also feasible when you're a small academic team, right? So the contributions of NeoBabel is that it is the first natively multilingual text-to-image generation model. We get this by creating a large multilingual image dataset. We have a unified multimodal architecture with what we call staged training, so that we very cleverly use the limited amount of data and the limited amount of compute we have to iteratively update the model. We propose new benchmarks to be able to measure multilingual text-to-image generation, and we propose an open toolkit for inclusive research. So let's start with the most important element is the data, right? So that is where we start with. So our first challenge was that high-quality multilingual data is very scarce, right? So there are hardly any data sets that combine image and language multilingual image data. So we started from a bunch of publicly available English-only image caption or image data sets. So here you see an overview. And I know that many of you are not from computer vision, so you may not be familiar with these particular acronyms in this table. Well, ImageNet you may know. This is web data. It comes with class labels. This is closed captions, 12 million web images, also with alt text scraped from the HTML website in which these images are embedded. This is the segment anything dataset, 1 billion images, automatically transcribed with text with the Lava image language model. Leon is a European initiative of an open source alternative to clip size datasets. It's from web data, and then JourneyDB is from Midjourney. So this is synthetic data because we also need to train our model with fake synthetic data, and a dataset from Blip Trio, which is a combination of data harvested from the web plus automatically generated data that is transcribed by GPT-4o and a human operator. Okay, so we take this as a basis, a total of 34 million captioned images, and we are going to expand it to make it multilingual. So how do we go about? Now, actually, the process is quite straightforward. So we take an experimental model from Gemini by Google. We take the ImageNet dataset in this example. That is an image that comes with a noun describing the main object in the image, and we simply translate it into the 6 languages. So here you have a streetcar, an American camelon, and a Bernese mountain dog. That is all then translated in the other 5 languages that we consider. So that's easy. We also do recaptioning. So there are datasets that come with an image and a caption. And then we use an off-the-shelf vision language model to recaption this particular sentence to make it more descriptive, more precise, right? So the caption here reads, "The Scotch House Vintage Black Velvet Scottish Kilt Style Jacket 3." And by taking the image content and the original caption into account, we recaption this one with this intern VL model, right? So without human intervention. And then it becomes, this image displays a black velvet jacket with silver buttons on a white mannequin. The jacket is tailored with a fitted waist and peaked labels. The mannequin is wearing a black velvet bow tie. The jacket has 3 silver buttons on the front and 4 silver buttons on each sleeve. The background is a white brick wall. The style of the image is a fashion photograph. So much more dense and precise description that we get from simply recaptioning it with a vision language model. So we also use images from JourneyDB. So these are synthetic images created by Midjourney. And again, we use the same trick. So we have the original caption and that we recaption again with this foundation model. So you get a much richer description. Richer and more precise, and that is important when we're going to learn the connection between the language and the pixels later on. We can also do the translation, and here we use the model called No Language Left Behind from a consortium of Meta AI, UC Berkeley, and Johns Hopkins University, so to provide also other languages for this image. And finally, we also take the very synthetic images that you will not find in real-world data, together with the sentences from Blip 3.0, and also provide the same trick. So we get the translations. Now, after this exercise, we have expanded the existing English-only datasets substantially with multilingual equivalents for a total of 124 million captioned images, right? So we have created a rich multiplication of the original dataset covering the 6 languages we are interested in for the moment. So now we're going to talk about how do we train this model with all this data. And we use a so-called unified architecture that is able to do generation and understanding. What we do is we use modern off-the-shelf tokenizers. So for the text, the texture modality, we use the Gemma 2 tokenizer by Google. For the image data, we use the MACVIT 2 tokenizer, version 2 to be precise. And this is pre-trained by people from the Show model. Then we have text tokens and image tokens, and we combine this in a unified space, which then forms the input for an LLM-based decoder. And this is also Gemma 2. So the tokens are image and text, but they are treated as one and the same LLM-like token by the text decoder. We also have a hybrid attention mechanism where for the text tokens we use a causal attention mechanism because that is the natural order in language, right? So you have a part of a sentence or you predict the next word, so that is the causality. But for the image, causality doesn't make too much sense, so we use bidirectional attention, and every patch in the image can attend to any patch, other patch in the image. Now, to train this model, we use a technique called discrete masked image modeling. So what we were going to do is we have an image and we randomly mask one patch, and then the task of the model is to sort of like fill in the blank and predict what the pixels should look like, right? That is how we do it. We start with one mask, one small patch that is masked in the image, and we gradually increase the number of masks until the entire In the end, the entire image is masked, and it is then able to predict the content, so to say. This is also what we do at inference. We have a completely masked image, and then the goal is to fill it in given a sentence. And now comes the secret meat of the approach, and that is the training of the architecture. And we use a stage training where we sort of like cleverly use the diversity of the data that we have created in a staged approach. So in stage 1 is what we call pixel dependency learning. And here we use essentially the ImageNet data, but then the expanded one with 6 different languages. So this is sort of like to start the foundation and learn the connection between the pixels and the 6 languages, right? This is a total of 6 million images, and we use 256 by 256 resolution. In stage 2, we are going to scale up the data, and also the text descriptions of the images becomes longer. So where in ImageNet we only have a noun, now we go into sort of more like sentence-like descriptions of the images. So this is for really grounding the image data in the text, right? And then there is a third stage where we do a refinement, and in this stage also synthetic data comes into the mix, so that the model has not only seen real-world photos, so to say, but also become more fantasy-like. This is the first stage, the progressive pre-training. Then follows a progressive instruction tuning stage that we do after this one. And as you can see on the right, here we scale up the resolution a little bit of the images. Scaling up the resolutions allows you to make more beautiful pictures, but it's very expensive at training time, right? So that is why we split this first to smaller images and then larger images. Here we use the more synthetic-oriented datasets with a very lengthy description, so very precise, and the content can be anything. Then we have trained our model, and we are ready to evaluate. But how do you evaluate multilingual aspects if all the benchmarks in the world are also English only? So we had to expand 2 existing benchmarks. We also proposed new metrics, but I will not talk about it in this talk. Let me focus on the 2 benchmarks. So the first one is GenEval. So let me explain to you how benchmarking text-to-image generation works. So this is work by Drew Baroche et al. Appeared in NeurIPS. So they defined 6 object-focused tasks that allow to evaluate generated images. So you start with a sentence. So here a photo of a purple backpack and a white umbrella. You send that to your text-to-image generation model, and then because they know the queries, you can run sort of like off-the-shelf object detectors to recognize, is there indeed a backpack in the image? Is there a umbrella in the image? Is it indeed purple? Is the other one white? And for this they use off-the-shelf object detectors and also an off-the-shelf image classifier using a large VIT. From Clip. Then, so they have these verifiers. If you have the verify correct, you score a point, and then you simply average all the items per task. Now, making this multilingual is straightforward. So rather than having only 1 input sentence, you create 6 different input sentences, and in the metric, you only have to add that you also average per language. Right, so that is straightforward. Now let's look at some results. So on the left, you see 5 state-of-the-art text-to-image generation models, and on the x-axis you see the different tasks that are part of this GenEval benchmark. Now the first, and this is for French, Hindi, and Persian. The first row is the Show-O model. This one has an English-only LLM inside under the hood. So as soon as you ask it things in French or Hindi, it starts to collapse. It simply cannot do it. Blip3o and Janus Pro have a multilingual LLM under the hood, but their multilingual LLM is not connected to the pixels. So they can do it to some extent, but they fail most of the time. On the bottom is our NeoBabel model that can do a good job regardless of the task or the language. So that is the value that we bring. Here are some qualitative results for Dutch. Now, most of you don't speak Dutch, so let me highlight you one of them that I find particularly funny, is the second one. So this is, I will translate it for you. Show a photo of a dinner table together with a bear. But in Dutch, the word bear is spelled as beer. And then if you have an English native or English biased model, it will take the beer because that is much more common. And the NeoBabel one does it correct. So we get the actual bear inside the image. So here you see the disadvantage of this English only model, because it has a really strong bias towards English, right? And with a multilingual LLM only, you cannot resolve it. You really need to learn the connection between the pixels and the text. Now here's an other benchmark to evaluate text-to-image generation. This one is called DPG, so it has a slightly different evaluation protocol. So here you have a sentence like a majestic parrot with vibrant green blah, 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 blah. It goes into your text-to-image model, and then it is evaluated by a VKA model. So you can ask it questions. Is there a parrot? Is there a sky? Does the parrot have a wingspan? So this is related to the input query. So you check whether the generated image has these aspects. If it is all positive, you score points, and then you have a means to evaluate. Now, you can also, again, make this multilingual by translating the input prompt and making sure you evaluate for each language individually. Here are the results. So what we see here, that for English, we are not the best in this benchmark. There are better models available, especially the ones that have more parameters. So Janus Pro excels here at 7 billion parameters, where ours has 2 billion. But I think the more interesting part is that for all the other languages, the NeoBabel one outperforms all of them. Now, this is a more evolved plot showing the impact of different training stages. Let me not go into too much detail here. The point is that by having this multilingual data and having quality in good translations and recaptures there, that really sort of like boosts your training process, right? And it depends a little bit on the benchmark, whether it is in the pre-training or the emphasis is on the instruction tuning. So that depends. But when you combine the two, it is always the better approach. And this really drives generalization. Briefly about applications. So what does this enable now that we are multilingual? So first of all, we can do multilingual in painting. So you have an image and a certain mask, and you can sort of like structure it in the way you want, no matter the language. A more interesting one is this one, is code switching, because this sort of like enables collaboration across cultures, right? So you can use your own language and work together with somebody else. So here the prompt is multilingual. So we have a close-up photograph of a corgi dog. Then we switch to Dutch. De hond draagt een zwarte hoed en een ronde donkere zonnebril. And then it switches to French. Le corgi a une expression joyeuse avec la bouche ouverte et la langue tirée dans une impression de bonheur ou d'excitation. And for convenience, I've added the English translation below, but it is not what the model sees, right? So it uses a mix of languages and it generates the picture you see on the right. This is not possible with other models. Then, with 1 minute to go, Last but certainly not least, this is all open and inclusive. So we are releasing everything on this GitHub page. So for the moment it's predominantly paper and a little bit of data. We're working on the publishable version of our work, and then we will release everything to not give our competition a head start. So it will arrive soon. Stay tuned. And that brings me to my conclusion. Most important point, I think, multilingualism is a catalyst and it is not a trade-off. So by being multilingual from the start, we get really an advantage. So it pays off to be multilingual. It is not a afterthought, but it should be a primal design goal. NeoBabel is performant with the state of the art while being much smaller than the bigger models. We provide a curated dataset, a novel architecture, a progressive training strategy, and a rigorous evaluation framework that others can follow up upon. And we're making everything fully open and publicly available. So use as your liking and try to make it better. Thank you so much for your attention.
No. Any questions? Anything you would like to know now? Ooh, that's a whole bunch. So I'm going to try to do it in order that I see you, but I might ask you to raise your hand again. What's your name and what can we do for you?
My name is Umayma. I am constructor University, Bremen, Germany. My research field is about business intelligence and artificial intelligence. And my question is about the possibility to extend the non-English languages, more than 5 languages. Is it possible based on the proposed model or not? And I'm also have another question related to the app or the open platform. It is released or is still working on releasing this open platform?
So before you answer, just quickly, I have a lot of questions, so I'm going to ask you to answer briefly if possible.
Thank you for your question. Do I understand correctly that your first question was about can you easily expand the number of languages? So I think, so if we want to add German, for example, there are 2 tactics. You can say, look, we already have 6 languages, and if we combine that with the multilingual, maybe we get a good result. So that would be the easy way out. The better results you will get with retraining it again, also with German captured images.
And that is doable?
Yeah, it's a matter of effort. Yeah.
Okay. And the second part? So I'll come back to you so the rest can hear us.
Oh, the second part about the openness. Yeah, so we are working on the conference paper out of the paper is there. There is some part is already open, and as soon as the paper is submitted, it will be next month. We will release everything.
Okay. Yeah. Who are you? How can we help you?
So my name is Michael from Polytechnic University of the Philippines and Canadian University of Dubai. So my question is somehow related to that. So when you somehow add another language, for example, how will you consider the complexity of, for example, the phrases or grammar wise in terms of providing a more accurate results? Like there are some Asian languages that we're in. If you come to translate it in another language such as English, it would have a different meaning overall. So how would you be able?
Yes. So this is a great question. So at the moment we are using basically a model that does the translation, right? And although this model is quite good and covers quite a lot of languages, it's still biased. And many very small languages are not included or do not provide good translations. So we would need help from the people who speak the languages and to be involved because that's the only way.
Okay, over here.
My name is Shamim Parksad from Lehigh University in the US. So I also have 2 questions for you. One is that you talked about the multi-language models, and he suggested that you can also translate the prompts and get the response. So my first question is, have you compared these 2 and see whether you actually are getting better performance, both in terms of the results and also efficiency based on that? And the second part, without questioning the work that you've done, and I understand that an academic project has a lot of limitations, but I think the more useful and important part of this process would be to open the database to multilingual data. And do you know if there are efforts that are undergoing in that area to make sure that we actually can use a lot more data from multilingual backgrounds?
Yeah, thank you for your questions. So the first one, whether we compared with translation, no, we didn't. We did compare with other models that use only a multilingual LLM, so did not make the connection. So that is sort of comparable with a translation based approach. Obviously, we have to do for the paper, we have to do this experiment. So that is already on the list, but we haven't done so yet. Whether I'm up to date on efforts on providing making the data sets all multilingual, that is so far very limited. So maybe this work helps to make the community put more effort in making data sets multilingual. One problem is that many data sets originate from the web and that are collected by American companies, and also their research departments are creating the data sets, and they tend to be very English-centric so far. So maybe that can change.
Over here.
Okay, not to disturb you too much, just one question. Andrei Grabins from University of Ljubljana, Slovenia. Are you not concerned that this open approach that you have, I understand we are all in academic freedom, etc., but this will be sooner or later integrated into projects of big AI suppliers? So I think we should think European as well, or multilingual.
Yeah, that's but that would not be a bad outcome for us if they would also absorb more multilinguality. Then we have made our point also.
Okay, so it's definitely a possibility, but you would welcome it.
Yeah.
Yep.
Hello, my name is Rahul Dembani, and I'm a Marie Curie student based in Athens and University of Messina in Italy. So thanks for the wonderful presentation. First of all, my question is like, you have told me about you have done the benchmarking of two different FLGen and DPG something.
Yeah.
So the main thing is like, I understand the when you do the prompt, like there is a cat with the glasses and the hat. So like mostly the benchmark is done by like the object you define in the prompt. Based on that, these things are like included in the image, or also these two benchmarking also done like more the pixel wise and which model creates more realistic image or something like this. And the second question is like, for your future work, are you going to do something like, not rather than just translating every like caption like in a different languages, which take a lot of time to do training, and there is a problem, I understand, like beer and bear, like in the Dutch and the English, for sure this is a real problem, to go for the one language which will be the more powerful to eliminate, to do the training process of every different language model you need to translate and go for this, which will take a lot of time and more complex. Thanks so much.
Thank you. Yeah, to answer your first question, to evaluate more like the aesthetic value of the generated image, there are no real good benchmarks for that. So we picked two recent benchmarks that have traction in the community, that are currently sort of like the go-to benchmarks. They are indeed not perfect, but they give us a means to evaluate, does the image generate what is asked in the query? And whether it is then also visually pleasing, that is not taken into account. But if you looking at the results that we generated, it was not weird, so to say. On your second question, is there sort of like an Esperanto for text to image generation? Yeah, maybe. But it could very well be that maybe French is a better language to start from than English. We don't know. We have to investigate.
Esperanto, for the people who haven't lived that period? Can you explain it just a little bit?
Oh, this was sort of like intended to be sort of like a meta language of language so that we could all speak one language.
It didn't really took off, did it?
It didn't really work out. No.
Hi, I'm Stefano from Omnis and University of Trento. I have 3 questions for you. The
So we're going to do it in parts. So just do the first question first. He'll answer it. and- Yep.
okay,
Thank
makes
you.
sense. So the first one is we see that you use a non-language left behind as a translation model alongside Gemini. I'm curious about possible bias introduced by using just 2 models, and also about the, let's say, artifact that non-language left behind for sure introduced.
You are right. They bring their own biases too, and we have accepted them. So we have not really looked into that. Yeah.
So then the second question is about the fact that did you consider to use just a model that, let's say, is trained to align just the transcription of the text and then use the embedding resulting from these to generate the image? So basically, let's say, trying to find something more efficient to align the model only on the language and then use the representation, which should be aligned for every language to generate the image.
Yeah, that is another tactic that we have not explored, but that would also be interesting. So I mean, I'm not saying that this representation we chose is the best one. It is a representation that made it work, but it could certainly use more work.
And then,
Yeah.
already answered.
Thank you.
Thanks so much. We had 2 more questions. Start over here.
Hello, my name is Michael from Austria, University of Technology in Graz. And I have a question regarding what's your gut feeling? Does the multiplicity of languages multiply the data for the training? So you have one picture, but several languages. And how does this map to the number of parameters in your model? So you have more languages, but less parameters. If you add now one language, well, what's your feeling? Do you need less parameters because you get more training data, let's say, out of the same number of samples? Or what was an easy interpretation for us?
Yeah, unfortunately, no. When we add more languages, we need more parameters. That is what our current finding. So we could squeeze it into 2 billion with 6, but if we add more languages, we will likely have to expand. At least using the current architecture, right? So relating to the previous question, maybe there is a more efficient way to encode all these languages. Because we use one model, one encoding for the images, for each language we have different. So maybe there is some gain.
The data get bigger. Let's say your data set gets bigger at the, let's say, same number of pictures.
Yeah, the number of pictures is fixed, but the number of language translations is growing. Yeah. And this is a careful balancing act between data and parameters and compute. And so,
Final question is for you.
Hello, my name is Cheikh Khan. I'm from Senegal, Cheikh Anta Diop University. My question is about sampling diversity. When I was wondering, because you've used multiple languages, does the model have some kind of cultural understanding? Like if I ask, can I get a picture of a dish? Would it be, if I write it in Dutch, would I get a Dutch dish? If I write it in French, would I get a French? Does it have that kind of a understanding just based on the training? Thank you.
great question. So at the moment, you could argue that our images are biased too, because we don't have a lot of images from Senegal, I'm sure, in the database. So I think a logical next step of our work is to also link this to culture, not only to language, but also to make it cultural. So if you ask for if you ask for a city scene and you're from Amsterdam, or you ask for a city scene and you're from Tokyo, it will look quite different. What you sort of like expect, right? And that is currently not part of the model, but that would be very interesting to make that sort of like the next step, so that it also sort of like is culturally grounded.
Okay. Thanks so much. Kees, Snoek.